Good morning. Let's start our lecture. We'll continue to study so-called conic section, and now we are going to consider the second example of the conic section, so-called ellipse. I recall the definition of the ellipse. Definition. The definition of ellipse is the same the definition of the previous definition of the parabola, and ellipse uniquely defined by choosing of some fixed point and the straight line. Given a fixed point f and a fixed line L. An ellipse is the locus of the point P which moves such that so that the ratio of its distances from P and A is constant. Less than 1. Namely, the ratio HP RP is equal E less 1. We have the point F and straight line A, and let's P be the moving point, and the locus of its point is the above defined ellipse, and R be the base of perpendicular to the straight line A which pass through the point P, and the ratio length of segment FP and PR is constant for any point of the locus of this point P. And let A be the same point which lies on the straight line which perpendicular to our fixed straight line L and pass through the point through our fixed point P. And K, let be K, is the intersection point of our fixed straight line L and our perpendicular which pass through F to our straight line A. And in this case, the ratio FA to AK is also is equal the ratio of P RP and is equal E. E some parameter which less than 1. And we have this locus. I'm sorry, I have this part of our draw, and I have the less scale I need in the less scale. Let F be our fixed point, P be moving point, R be the point as above, and let K be the base of perpendicular, and A be the intersection. Let's our perpendicular to the straight line FK be perpendicular to our straight line L, and A be the point of our locus, and then the ratio F A to AK is E. As above, E is called eccentricity of our curve, which defined by this condition. And let consider the extension and consider the point A prime, other point on our straight line, such that the ratio of the A prime F to the FK be also equal the eccentricity E, and A prime be other point which lies on our perpendicular and belongs to the our locus, which defined above mentioned condition, namely A prime is other point which lies on the perpendicular to the straight line A. And let O be the middle point, of segment A prime A, namely let O be such point that the distance O A prime is equal OA, or the middle of the segment A prime A. And let calculate the length of the segments OA, which equal OA prime. Any question, maybe? No? Mm-hmm. Do you understand our draw? Yeah? Have any question? And I briefly repeat the main idea. We try to define the other kind of so-called conic section. All kinds of conic section is defined by the following condition. We fix some point A. We have some fixed point and some fixed straight line A. We have two parameters. And other parameter, the number E, which less than 1. And our curve uniquely define these three parameters. Namely, our curve is the locus of the point P, which defines the following condition. The distance, the ratio of distance between this moving point P to F and distance to our fixed straight line L is constant, which equal E. This condition is uniquely define our curve, our conic section. And using this condition, we'll try to get the exact equation of this straight line. And we first step to obtain the equation of our curve is to calculate the two distance. Namely, let's consider the perpendicular which pass through fixed point F and perpendicular to our straight line. And this perpendicular, on this perpendicular lies point A, which belongs our locus, our curve. This point is uniquely defined by the same condition. The ratio FA to the AK is equal eccentricity, is equal E. And after them, let's consider other point A prime, which also belongs to our perpendicular and belong to the locus, our above defined locus, namely belongs to the ellipse. And this other straight line is uniquely defined by the condition, the ratio A prime F to the Fk is the E eccentricity. And after them, we consider the middle point of the segment A prime A, the middle point. And first step to calculate the distance between A prime and A is so-called extremal point, which belongs to our locus and lies on this perpendicular to our fixed straight line. easy to see if point P moving on our straight line such that this ratio to the distance, to the f and straight line is constant, and these 2 points, the extremal point of our curve. And let's calculate this distance. We can we have to compare the distance between OF and OA. Easy to see that A prime A is equal to O A prime, and A prime and A prime A is the sum A prime F plus F A. This distance is equal from one hand is the sum of the distance A prime O plus OA, and other hand is the sum A prime F plus F A. FA, and A prime F. And other hand, F Fk Fk we have also R prime OK we try to compare OF and OA. OF we can consider the A prime F Fk is equal E. A prime F is equal E Fk. E Fk. And AF is equal I'm sorry, AF from this condition is equal this might be a mistake, A prime F Fk is equal Fk oh sorry A prime K this mistake A prime K I'm sorry the mistake A prime the ratio A prime F to the A prime K is equal E. This mistake. It's right. And we can deduce from these equalities the following equality. A prime from this equality AK, and from this we can deduce, we can rewrite this equality such that FA is equal E AK. And we can to add this one and this one. A prime F A prime is equal A prime F plus FA, and is equal E times A prime K plus A prime K plus AK. A prime K plus AK. And easy to see that OA easy to see that easy to see that O I assert that this sum A prime K plus AK is equal twice twice OA. Let's rewrite this equality. OF A prime A A prime A is equal A prime F plus FA is equal E A prime k, a prime k plus ak plus ak. Easy to see. The left side a prime a is equal twice o a, and a prime k plus a k. A prime k I'm sorry. Maybe a mistake, I'm sorry. Let's denote by OF by A. OF by A. And this is equal OF. And A prime k plus this one. K A is equal the equal difference OK minus OA minus OA. OP minus OA. And KA is equal the difference OP minus OA. AK. And plus and the sum A prime K is equal R prime plus AK and we obtain this sum KA OK minus OA and A prime became O A prime O A prime plus I'm sorry, OK minus O, yes, O A prime plus K A, I'm sorry, A prime K minus A K O A prime plus A prime K. A prime K is the sum KA is a difference between O A I'm sorry, that's
don't. A prime K is then O A prime plus AK. I think you have a mistake there.
Yeah. Just a minute. K. Let's repeat. We have a straight line A, the point F, the point A, the point A prime, and we have the sum KA, and I'm sorry, A prime F plus FA plus FA. This right equality A prime K plus AK. Okay, this A prime K. This is easy to see. A prime K is equal to A prime. A prime K is this mistake. A prime K2 to OA. A prime K is A prime O plus OA and plus AK. And KA OK minus OA. we must to obtain A prime A in this case, and to this may be a mistake. I'm sorry. I'm sorry. Okay. KA KA prime is right. KA O OA KA equal okay. Okay, okay, minus OA. Minus OA. That's right. A prime K. A prime K O plus OA and plus AK. Plus AK. Maybe. Okay. I must to get the following equality. A prime A prime is A prime, maybe mistake. Let's consider again. Maybe we have some point F, we have some straight line A. We have K, R, A, other point A prime, such and we have the following equality I prime f to a prime k is equal f is equal e. The ratio a f a k is equal e, and I try to I prime f is equal I prime k e plus fa plus fa e ak, and let's consider f prime a minus fa we have also consider a prime f plus fa is equal e ka prime plus ka is above mentioned. And let's O be the middle. O be the middle of the segment A prime A, and let OA is equal A. OA is equal A, and OF is a difference. OF is a difference. OA minus FA. And let's analyze this equality. A prime F plus FA is equal A prime A. A prime A. And KO, okay, this this equality, let's analyze this equality. K A prime plus K A let's consider OK. I assert this this sum is twice OK. Easy to see that Ki prime is equal Ki prime is equal twice OA plus AK. Ka prime is the sum. A prime O is equal OA, and A prime A is equal twice OA, and plus AK. And other summand which also equal AK. And we obtain this equality is equal to E OA plus AK is exactly equal OK. This equality, and we obtain that left hand is equal AA prime, which AA prime is equal to OA, and we obtain to OA is equal to E OK. OA is equal E OK. And we obtain that OK is equal the ratio OA to E. Let's denote OA by a little a. This difference we denote by A. And after them, we obtain that is equal A, the ratio AE. This difference is the ratio AE. And first step, we express the distance between point O and our fixed straight line as the ratio AE, the first step. And after them, let's compare the distance between OF and OA. Easy to see that OF is the difference between OA and FA. FA prime, FA, the second step, FA prime minus FA prime minus FA is equal twice f twice OF. If we can consider the point f prime, which be symmetric to the f relatively the middle point O, and easy to see that the difference, the distance A prime f is the difference between the distance A prime f minus fa is equal A prime f, and we obtain f prime f onto OF, and easy to see that fa prime we have fa prime is equal epsilon A prime k, and fi is E A k, and this difference is equal E times A prime k minus A k. A prime k minus A k is equal twice OA is equal twice EA, and we obtain OF is equal EA, and after our hard calculation, we obtain the following two formulas. OF is equal E times A, and OK is equal A, the ratio AE. This one is distance between between our fixed point F and middle point O. This distance is some fixed parameter A. To A, the distance between point A prime and A, the extremal point of our curve, which lie on the perpendicular to the straight line, to fixed straight line A. And the second distance between O and straight line K. And we obtain the following two ratio. And we obtain the following picture. Straight line L, fixed point F, A, the moving the other point A prime, the middle O, the middle of the segment A prime A, and we also introduce the point f prime, which is symmetric to point f onto middle O. We have the following symmetric picture: O, the middle of the segment A prime A, and also O, the middle of the segment F prime F. And we have some point K is a point intersection of the perpendicular A prime A to A with A. And we have the following ratio. I'm sorry, not OF, OA is equal A, OA. And we have two following ratio. The ratio OF to OA is OF to OA is equal E, and such that OF is equal E OA is equal EA. OA is equal A. And OK is equal OA, the ratio OAE. The ratio AE. We have the following picture. After these two steps, we can deduce the equation for our curve. We have two basic ratios. We will use these formulas and deduce the formula for our curve. Let's consider coordinate system. The following coordinate system. Let x-axis coincide with this perpendicular, and O be the origin of our coordinate system. And let A and A prime be the point which has A has coordinate little a0, A prime minus a0, and F has coordinate EA, EA0, F. And let P the arbitrary point with coordinate x, y, and R has the first coordinate A and second coordinate y. And we have the following equality. The distance FP, the ratio distances FP and PR is equal epsilon. Easy to see that the distance fp is equal x minus a square plus y, root square, the square of p. And PR, this distance, is equal a minus x. And we have this ratio, which we can rewrite in the following form. You can write in the following form. Fp square is equal, E, not epsilon, E square times PR square. Fp square is equal x minus a square plus y square, E square times a minus x square. And after easy simplification, we obtain x square minus 2a x plus a square plus y square is equal E square x square minus maybe a mistake. I'm sorry. RP, mistake. This mistake. X minus EI. I'm sorry. FP X minus EA minus EA square. I'm sorry. I'm sorry. And the straight line K has coordinate the ratio AE, and and this distance, excuse me, this distance is a difference the ratio AX, AE minus X. Excuse me. Excuse me. F has a coordinate AE 0, A has coordinate A0, and K has coordinate the ratio AE0. And we have some point P which has a coordinate xy, and let R has coordinate A, E, Y, and we have this ratio FP PR is equal E. And easy to see that FP is X RE, and we have X minus RE square plus Y square, and PR is equal the ratio AE minus X. And we have the following equality: FP is equal E PR. FP X minus AE square plus Y square. E times PR is equal E, the ratio AE minus X is equal A minus EX. And we obtain that X minus AE square plus Y square is equal A minus EX square. And after easy simplification, we obtain the equality X minus 2XAE plus A square E square plus Y square is equal A square minus 2AEX plus E square X square. And after easy simplification, we obtain the following equality: X square times 1 minus E square plus Y square is equal A square minus A square E square 1 minus E square. And we obtain the ratio x square a square plus y square a square is equal unit. Let's denote the product a square 1 minus e square by b square, and we obtain the following equality: x square a square plus y square b square. The ratio y square b square is equal 0, and we obtain the equation of ellipse. And let's draw this curve. Draw this curve. Easy to see, if y is equal 0, the ratio x square and a square is equal 1. And we obtain that x is equal plus minus a. And we obtain this point a prime a. Also, if x is equal 0, we obtain that the ratio y square b square is equal 1, and y is equal plus minus b. And we obtain this 2 point plus b minus b. And let's consider this obtain such figure. And easy to see, when y increase, x decrease, and we obtain the sum figure which has the following form. This is ellipse, and we have also 2 points f prime and this fixed straight line L, and we also consider the symmetric straight line L prime. L prime are called directrices. F prime are called foci. F be focus. And point A prime A, and also the point which has coordinates 0 b 0 minus b is called vertices. And we obtain the following feature, ellipse. And let's prove the following theorem. Theorem. If we consider point P of ellipse, the sum distances f prime p and pf is constant and is equal to A. Easy to see that the easy to see proof. F prime p is equal E f prime p is equal E PR. PR PR and symmetric, by symmetric way the distance f prime p is equal E PR prime. The first equality P R is equal X I'm sorry, the equal the ratio AE minus X this ratio is equal X this ratio is equal X minus X minus the ratio AE. This sum FP plus F prime P is equal the ratio excuse me, the product F prime P is equal E P R prime is equal E X plus the ratio A, and we obtain that the sum is equal to A, and we obtain this theorem. After them, let's consider the following geometrical illustration. First of all, we obtain the ellipse as a section of the cone by the some plane, which has some slope, and maybe a little later we obtain that this definition, we also can define the ellipse as a locus of the moving point, which has the following property: the sum of the distances to the fixed point for chi is constant. We can use the following naive picture. We have the sum rope and pencil, and we tense this rope and moving this pencil such that this string is be tense, and the figure which draws this pencil is the ellipse. And after them, I try to explain how this definition can be reformulated on the language of the natural conic section, and maybe a little later. And let's consider the other kind of the conic section, so-called hyperbola. The definition of hyperbola is the same as definition of ellipse, but the word sum we change sum of distances we change on the difference. Hyperbola. The definition: as above, given point P, point F, and a straight line, fixed straight line A. Hyperbola is the locus of the moving point P, a point P, moves so that the ratio of its distances from F and L is equal a constant greater than 1. We have the same picture as above, but in our picture the distance between point F, A, and distance the ratio of distance F P to R P is equal to some constant P which greater than 1. And our reasoning is the same as in a previous case. I haven't time, but I try to give the main idea of how deduce the formula for the hyperbola. The formula for this conic is the following: the ratio x square a square minus y square b square is equal 0. The main idea is the same as above. We have f, we have straight line A, and we have some point P. We also obtain the point A, which the point such that the ratio FA to AK is equal E. We also consider the symmetric point A prime such that the ratio FA prime A prime K is equal E, and we can consider also symmetric point F prime and calculate, and we consider the middle point O, the middle point of the segment A prime A, and we calculate the distance FO and OA, and consider these two, and we also consider some point K, point for some point K, and we compare these values FO, OA, and OK. Let's OA is equal A, OF is equal A times E, and OK is equal the ratio AE. We obtain the same values for main parameter of the hyperbola, and after the same calculation we obtain the same formula: the ratio x square a square minus y square a square e square minus 1 is equal 1. The first part of this reasoning. I need in our seminar in this formula, and we will use this formula. And at the next lecture, I repeat this reasoning, and we obtain the formula for hyperbola explicitly and using the explicit reasoning. I haven't any time, and I finish.